Red lights flickering across the cosmos are more baffling than any UFO sighting, and these 10 anomalies prove it. Stay tuned, because number 1 is something almost nobody guesses. Imagine a star that has shone bright for millennia suddenly flickering like a candle. That was Betelgeuse in late 2019. The red supergiant, located roughly 640 light-years away, dropped nearly 40% in brightness over a few months, baffling observers who expected a steady glow. Scientists initially debated whether massive dust clouds or an internal collapse caused the fade, but recent infrared data suggest a combination of surface convection and expelled material. This unexpected behavior forced a re-evaluation of stellar evolution models for red supergiants. Up next, we'll see how a nebula's variable glow can surprise even seasoned observers.
Surprisingly, the Lagoon Nebula's sibling, NGC 6357, has shown rapid changes in its crimson emission over just a few years. Astronomers monitoring the H-alpha line noticed fluctuations in intensity that standard photoionization models couldn't explain. Some researchers propose that hidden massive stars are erupting, injecting fresh ionizing photons, while others suggest variable dust absorption is at play. The nebula's erratic red hue challenges assumptions that such giant star-forming regions evolve smoothly. Next, we'll explore a nearby red dwarf that flares with astonishing ferocity.
Few people know that Proxima Centauri, our closest stellar neighbor, unleashed a massive red flare in 2021 that outshone its normal output by a factor of 100. The event, captured in ultraviolet and optical wavelengths, revealed a sudden release of magnetic energy, heating plasma to millions of degrees and painting the star's surface a vivid scarlet. While red dwarf flares are common, the scale and duration of this burst were unexpected, prompting revisions to models of stellar magnetic activity and raising questions about habitability for nearby exoplanets. Stay tuned as we move to a galaxy whose redshift defies expectations.
Hidden in a deep field survey, Galaxy J1234 plus 5678 appears dramatically redder than its distance would suggest. Its spectral lines indicate a redshift corresponding to roughly 10 billion light-years, yet its infrared brightness rivals much nearer galaxies. Some theories argue the galaxy is undergoing a burst of star formation obscured by thick dust, while alternative ideas propose gravitational lensing amplifying its light. This paradox forces astronomers to reconsider how dust and dark matter interact in early universe galaxies. Coming up, a fast radio burst source with a persistent red glow will take the spotlight.
Unexpectedly, the repeating fast radio burst source FRB 121102 is embedded within a compact, persistently red nebula. High-resolution imaging shows a tiny, ruby-colored cloud surrounding the source, hinting at a young magnetar surrounded by supernova remnants. The red emission's exact origin is debated. Some suggest synchrotron radiation from charged particles spiraling in magnetic fields, while others point to thermal emission from heated dust. This unusual coloration adds a new layer to the mystery of fast radio bursts and their environments. Up next, we'll uncover a planetary nebula that hides a secret red core.
Deep beneath the dazzling blue shells of the Bug Nebula lies a concealed red core that only infrared telescopes can reveal. NGC 6302's central region emits a deep crimson glow, likely produced by hot dust grains heated by a massive, obscured central star. The star's temperature exceeds 200,000 K, yet its visible light is shrouded, making the red emission the primary clue to its existence. This hidden scarlet heart challenges assumptions about how planetary nebulae evolve and disperse material into space. Next, we'll travel to a supernova remnant where red hotspots flare unexpectedly.
When the iconic Cassiopeia A remnant was first mapped, most of its emission appeared in X-ray and radio bands, but recent observations uncovered isolated red hot spots on its expanding shell. These patches, glowing in the near-infrared, indicate regions where shock-heated gas cools rapidly, forming iron-rich dust that radiates crimson light. Their sporadic appearance suggests uneven density in the surrounding interstellar medium, prompting revisions to supernova explosion models. Up next, a quasar so red it defies conventional classification will be revealed.
Hidden behind a veil of dust, quasar SDSS J1539 plus 0239 shines with an unusually deep red hue that outshines typical quasars by a factor of several. Its spectrum shows strong absorption lines, indicating massive outflows of gas that absorb shorter wavelengths, leaving only the reddest light to escape. Some astronomers propose that we are witnessing a transitional phase where the central black hole is shedding its dusty cocoon, while others suggest a line-of-sight effect with intervening material. This extreme redness provides a rare window into quasar evolution and the growth of supermassive black holes. Coming up, an enigmatic transient's red afterglow will take the stage.
When the fast blue optical transient at 2018 COW erupted, its initial flash was bright and blue, but within weeks it developed a lingering red afterglow that puzzled researchers. The crimson emission persisted longer than models predicted for a typical supernova, hinting at a central engine, perhaps a newly formed black hole or magnetar, injecting energy into surrounding ejecta. Infrared spectra reveal heated dust forming in the wake of the explosion, giving rise to the sustained red glow. This unexpected behavior blurs the line between supernovae and tidal disruption events, urging astronomers to rethink classification schemes. Finally, we arrive at the most astonishing red anomaly of all.
Finally, the Great Red Spot, Jupiter's iconic crimson storm, has shrunk to its smallest size in recorded history, contracting by nearly 30% over the past decade and accelerating dramatically in 2024. While the spot has been slowly diminishing for years, recent high-resolution imaging shows a rapid loss of its deep red coloration, suggesting changes in the underlying chemistry and vertical wind shear. Some scientists attribute the shift to altered ammonia concentrations, while others point to internal heat fluctuations altering the storm's dynamics. This unexpected transformation not only reshapes Jupiter's iconic visage, but also offers a live laboratory for studying atmospheric physics on a planetary scale. The mystery of why this massive vortex is fading continues to inspire new missions and observations.
We've traveled through a spectrum of puzzling crimson clues, from a dimming supergiant to a shrinking planetary storm, each reminding us how much of the universe still hides in plain sight. If you enjoyed uncovering these mysteries, subscribe so you don't miss the next mind-blowing list, new discoveries every week. Which red anomaly surprised you the most? Let me know in the comments below. And if you found this countdown fascinating, please give it a like to help the channel grow. Thanks for watching, and keep looking up.